Hey guys, in this video what I wanted to go over were some of the answers to the problems that we worked on in class today and actually give you some advice on trying to figure out problem number 3. If you look at the problem number 1 that we spent today on in class, basically we were working on Celsius to Fahrenheit scales and trying to come up with a formula to convert between them. Well, in problem number 1 we wanted to write the general equation of a line. And probably the most general equation that we can think of is one that you remember from 8th grade, which is just y equals mx plus b. And one person actually brought up that that was slope-intercept form, which is perfectly acceptable. So we would call this slope-intercept form right here. The other type of equation that you could have also written was one that's called ax plus by equals, and then something called c, and this right here would have been called the standard equation. So either one of these would have been acceptable, but the one that you're going to probably find the most useful for this particular activity would be the slope-intercept form. Now, when you're looking at problem number 2 right here, where it says to define any quantities that would need to be known for converting from temperature in Celsius to temperature in Fahrenheit, remember part of the definition of quantities is anything that can be measured. Well, because this formula has to be able to go from Celsius to Fahrenheit or from Fahrenheit to Celsius, that means that you're actually going to be measuring two different things. And in our case, what we're going to be looking at is the idea that we are going to be measuring both a Fahrenheit and something else in Celsius. But the problem here is that if you think about this, and back to kind of a general conversation that we had in class, Fahrenheit is a scale. It's not really a quantity. It's not measurable. So what you think about is when you use Fahrenheit scale, what is it that you're actually measuring? What you're actually measuring is not a Fahrenheit, but you're actually just measuring a temperature, and it just happens to be placed on the Fahrenheit scale. So we could say that it's a Fahrenheit temperature. And then when you're thinking about the same idea here with the Celsius, Celsius is a scale, and what you're doing is saying that you're going to be measuring Celsius temperature as well. Now this right here outlines the quantities that are involved. So Fahrenheit temperature and Celsius temperature are quantities. The problem is that this says to define any quantities that you would need to know, and we know that part of what we need to practice in order to show mathematical proficiency is that when we define a quantity, we also define if it is something that will be fixed or variable. Well, because we're trying to develop a formula, there's obviously going to need to be a variable for both the Fahrenheit temperature and the Celsius temperature. So for this example, why don't we just say that f, I'm going to use a lowercase f here and actually make my handwriting look a little bit better there. We're going to use a lowercase f for Fahrenheit temperature and a lowercase c for Celsius temperature. Now this will help kind of get you started on problem number 3. To get you started on problem number 3, remember what problem number 3 asked you to do was to create two ordered pairs of related temperatures and explain why they would be logical. So let's think about this here for a second. From the warm-up that we did earlier in class, what we absolutely all agreed on was that for water's boiling point would help if I make that look like a B, for the boiling point of water, we know that the water's boiling point can be expressed in two different ways. We can say that the boiling point is either 100 degrees Celsius, or we can say that it is 212 degrees Fahrenheit. Then we also had to look at the freezing point of water. And from our warm-up, we found out that the freezing point of water was either 0 degrees Celsius or 32 degrees Fahrenheit. Well, if you think about this, when you're trying to visualize a formula, and we know that this formula is linear, that means that these would actually look like some kind of a relationship where we could go from 100 degrees Celsius to 212 degrees Fahrenheit And the same formula can take us from 0 degrees Celsius to 32 degrees Fahrenheit. So generally drawing a sketch here of what this might look like if we were to think about this formula as a graph, we would see something where we would have our graph and then some kind of a line where we would say, hey, this line could look something like this maybe, in red. Well, this red line would be the actual relationship between these two different quantities here. So one of the quantities would have to be identified as Celsius, the other one as Fahrenheit, but then remember the quantities would have to be either labeled as dependent or independent, and that's going to be based on your formula. So what that means is that one of these axes is going to have to be F, the other one's going to have to be C, relating the two together. Well, that ultimately means that when we go to take a look at our idea of relating freezing point and boiling point, we know that freezing point might be somewhere right here, basically showing that at this particular point on the Fahrenheit scale, the water would, I'm sorry, let's do boiling there, that it would boil, and then at this particular point here at Celsius, it would boil as well. But then there would be a different point on the line, say right here, that could show freezing, and that would have at a different point on the Fahrenheit and a different point on the Celsius. So when you think about trying to relate these as ordered pairs, remember, you're having to think about these as dots, and would the ordered pair represent the same thing? So in this case, these two quantities, or this one quantity and measurement here would be an ordered pair, and you could write it using an ordered pair, and then this would be another ordered pair right here as well that you would write as an ordered pair. And then the big question is, why would it logically make sense to relate these two numbers together and these two numbers together? I'm going to leave that as an exercise for you to talk about in your homework tonight. Think about it, kind of mull it over, and then when you come in tomorrow, one of the first questions I'm going to ask you at the door is, why would it make sense for boiling point and freezing points to be made into an ordered pair? And be ready to discuss that when you come in through the door. Look forward to seeing you guys tomorrow, and we'll pick up with this activity then. Bye-bye.